Good morning, algebra students. We're looking at our lesson 2-2 today, exponent properties. So our first little line here says that you can multiply and divide exponents that have the same bases. And so remember, when we're talking about bases, we're talking about that base that's being raised to some exponent. That base raised to an exponent. They must have the same bases. If they don't have the same bases, then you cannot simplify them. So the first rule that we're going to look at, which might be something that you are familiar with, it's definitely something you looked at in 8th grade, is a multiplication property. If you have x to the a power times times x to the b power, that results in x to the a plus b. Notice the bases are the same here. Both of these bases are x's. Bases are the same. So watch out for that. Let's look at some examples. In the first one, we have x to the 5th times x to the 3rd. And now remember, if you're ever in doubt or you're ever unsure about something, you always have that option, or you can always go back to the facts that exponents represent repeated multiplication. Exponents are repeated multiplication. Repeated multiplication. So for this first example, x to the 5th would be x times x times x times x times x times x to the 3rd would be x times x times x. If I count up all those x's, the 5 plus the 3, just like it tells me to do in that multiplication rule, that a plus b, 5 plus 3, would leave me with an x to the 8th. Now in example 2 here, I have x to the 7th times y to the 7th. That cannot actually be simplified at all because the bases are not the same. So this is already simplified. The bases are not the same. So you could rewrite that, you could just rewrite it as x to the 7th, y to the 7th, but there's really nothing else that's the same as that. Example 3, getting a little bit more complicated here. Here I've got some parentheses going on. I've got exponents. Let's take a look at this. So the first thing when you're looking at this, that 4 is not attached to that x to the 5th. That 3 is not attached to that x to the 6th, and that 2 is not really attached to that x either. All of those pieces could be moved around. And now notice when we're looking at this here, even though the 3x to the 6th is in parentheses, that exponent is still only being applied to the x. In order for it to be applied to the 3 and the x, it would have to be on the outside of those parentheses, which it is not. So that's going to play a huge difference here. So when we're looking at this, we want to just focus on the numbers first. Because there's no exponents outside of those parentheses, I just want to focus on my numbers. So I have 2 times 4 times 3. And I know that everything here is multiplication because I don't see any other kind of operation sign or anything else other than those parentheses. So I'm knowing and assuming that that's multiplication. And then I can look at the x pieces separately. I've got x times x to the 5th times x to the 6th. Well, 2 times 4 is 8, times 3 is 24. X times x to the 5th is x to the 6th, because remember, I'm using that adding rule, times another x to the 6th. And remember, if you're ever stuck, just think about what it would look like expanded. X to the 6th would look like 6x's being multiplied, and then another 6x's being multiplied, which just results to 12x's being multiplied by themselves. So 24x to the 12th power is your simplified answer. And we'll just look at example 4, and then that'll be it for this video. Example 4 is just like the example going on in 3 here. That shouldn't be a 0. That's not a good example because we didn't talk about 0 properties yet, but we'll talk. But anyways, so same kind of problem as example 3. It's all multiplication going on between everything. There's just no parentheses, which is still okay because we know that without any operation, we know it's all multiplication. So same kind of thing here. I'm going to start with looking at my numbers, and all I have is a 4, so that 4 is just going to stay the same. I have x to the third times x to the 0. I have y squared times y cubed, and then I have a little lonely z there. And remember, none of those pieces are attached to each other. I can move all of those around because of the commutative property, the fact that 4 times 5 is the same thing as 5 times 4. So I'm just going to do some simplifying. This 4 comes down, x to the third times x to the 0. My multiplication rule tells me to add. 3 plus 0 is just 3, so that's going to stay x to the third. Y squared times y to the third power. Be careful here that you're not turning that into a 6. 2 of the y's times plus the 3 y's gives me 5 y's. I'm doing that adding here. And then my little lonely z can just get carried down. And there is my simplified answer.